Good morning. So before we start, I'm going to tell you the following. First, we're being live streamed, so smile. You're not actually going to be on any of the videos, but if you ask any questions, we will ask the people helping us to hand you the microphone so that the participants can hear. Otherwise, as you can imagine, being on an online platform and not being able to hear what I'm actually trying to address will make it very confusing. Next thing, there is a Telegram group for the conference. There will be a beginner's track group-like message within the Telegram group, and there you will be able to find additional links, and we'll try to keep some communication on there. Apart from that, I will also want to say, welcome to the Introduction to Python. Oh, I will leave this on for a minute. It's just true. I just said this.
So, I just wanted to have a small remark. These sessions are being also recorded and will be uploaded to YouTube later. If you have any questions, please wait for the microphone. Thank you very much.
And to be fully transparent, I will be asking you questions. So, are we ready to move on? Anybody else want to scan the Telegram before I change? I see at least one person, so I'm going to wait for a second or two. Hello, welcome. Okay, so I'm going to go ahead and move on. Well, let me be the first to welcome you to the Introduction to Python tutorial. My name is Milton Gomez, and let me go ahead and start by introducing myself. I'm a second-year PhD student working with Tom Buckler at the University of Lausanne. I'm working on the use of artificial intelligence and meteorology, and today, I want to ask you, are you new to scientific computing? If you're so, please raise your hand. Okay. And how many of you are familiar with scientific computing but are new to Python? How many of you have some experience with Python? Okay. So, we'll go into the very basics of using Python for scientific computing, and what should you expect to be able to do by the end of the course. We want you to be able to describe Python in very broad terms, to indicating the reasons for using Python in a scientific environment, to identify variable types, the basic variable types, and also container types in Python. Hello. To understand how conditional loops and functions work in Python, and to develop an intuition for how objects work in Python. So with that in mind, can you describe Python for me? I know there are some people who are familiar with it, so. And as a reminder, or rather as a first introduction to this, I'll take about 10 seconds to allow people to come up with a response. Otherwise, I'm going to move on. And to do that, I'm going to use my hand and count to 5 and then count back down. So can anybody describe Python for me? Oh, can I ask you to please hand the microphone?
Yes.
Just very briefly, abstract object-oriented programming language.
An abstract object-oriented programming language. That's one way to describe it. Any others? Okay, so what I want you to take away from what Python is, it's a high-level programming language. So take a moment to look at the code over there. How many of you think that you have an idea of what the code does? hopefully it's something that looks somewhat easy to read. It's saying, my age is 36. And if my age is greater than 18, I'm an adult, otherwise I'm a minor, and then I'm just going to print that to the screen, right? Straightforward. Next thing, it's an interpreted language. If you grab this and you use a Python interpreter, you are not going to have to compile anything. You are going to be able to run things immediately. These two things have advantages and disadvantages. The first, it's easy to read, right? Interpret it. You don't have to compile things. You don't have to wait for things to be finished before trying to run things. You can try out small snippets of code at a time. It makes it a lot more interactive. Disadvantages. All of these high-level abstractions, all of these ways of interacting with the computer are less efficient, right? If you want to go into really, really fast code, I suggest you go into assembly. If you have a lot of time. Otherwise, try maybe C. And if you want to make sure that your things are easily understandable, let's go for Python. Why use Python? Well, here are the statistics on Stack Overflow, which is where you can get some questions answered whenever you have a problem. And you'll see that Python has become really popular over the years, right? You can make the comparisons to other programming languages on the right. And if you look at the big, nice logos that you have there, those are some libraries that you can use in order to make your life easier, including some for machine learning, including some for working with data frames, which are kind of like Excel sheets, and Matplotlib to make nice plots. If you are in the scientific environment, that will help you make very nice plots. Hello. So where are we going to start? We are going to be working with Jupyter Notebooks today. I believe most of you have followed the Jupyter Notebooks tutorials. And for today, I am going to suggest that you use either Binder or Collaboratory, or Colab for short, because that way you don't have to install anything. Everything is already on the cloud. I will personally be using Colab when I show things to you on the screen. In the meantime, I ask that you please open up the repository. There are two options to do this. You can scan the QR code, or you can follow the tiny URL. And so I'm going to give you a minute or two to do that. Quick show of hands, who needs a little bit more time? Okay, so hopefully by now you have something like this in front of your screen, right? This is the repository. And here, hopefully by now you see something like this on your screen. Yes? Okay, so if you look over here, you will have the list of the notebooks that we're going to be working with today. I suggest that you use Colab if you have a Google account, because Binder Hub can be limited in the number of users, while Colab, because it is funded by Google, allows as many people to get on there as necessary. I've never run into any problems. If you want to run things on Colab, just click on whichever notebook you want to open, and you will see an Open in Colab link. And you will get to the Colab interface. But before we start with that, I'm going to go back to the presentation and ask you a very important question. What type of information do we store in computers? Any volunteers? We need to ask you for the mic, if you don't mind.
Binary data.
Binary data, right? So you have things like true or false, right? That's one information. When you're using computers, most of the time, you're using things like numbers. You're trying to make calculations. You're using things like text, right? You have strings that you want to print. You have links whenever you type a link that you're trying to follow in a web browser, right? That's a certain amount of text that has a specific meaning. So how do we store all this information? Digitally, we use bits and bytes. So computers are a collection of switches, in essence, right? And so in order to be able to store information, we have to use switches in order to represent all the information that you have. Whether it's a simple integer, whether it's a float, whether it's a string. Ultimately, everything is going to come back down to the basic variable type of using bits. So take a moment right now, go to the 01 notebook inside of the repository, and spend, I'm going to give you about 10 minutes to go through it, and then we're going to move on to the next aspect. If you have any questions at any point, please just let us know, and we will address the question. Isn't it? recommend that you use. You just have to open it in Colab. You might want to try to do it locally. I recommend that you do online for today. So if you go to the repository, the link that I showed before. Let's see, where is that one? You can follow the tiny URL link. Quick show of hands. How many of you have finished with the notebook? Okay. I suggest if you're still working on it to try to address the main takeaways that are at the top, and because we're going to be moving on in a little bit. Okay, so hopefully by now you've looked a little bit at what are the numerical types in Python. So you should have looked at integers, you should have looked at floats, right? You should be familiar with some of the operators, the basic mathematical operators, plus, minus, division, modulus, which becomes important in different aspects. You should also hopefully be now familiar with logical operators and how to use them in Python. But I have a following question that I want to ask you. How do we group digital information? Because right now, you have individual little pieces of information, right? But what kind of grouping can you think for digital information? No? Okay. Okay. No, I thought I saw a hand. I'm good. So we want to store sequences of information, right? Oftentimes, we're not interested just in one number. We want to get a sequence of numbers. An example, you have the Fibonacci sequence, right? Additionally, you might want to be able to store multiple types of information associated with, for example, a student. What is their age, their nationality, what languages do they speak? You might also want to be able to store things like coordinate pairs, right? Oftentimes, if you're graphing or if you're trying to carry out complex information, you're going to need the features across multiple axes. So take this moment, open the 02 notebook, as you can see on the top right, and start going into container types. And containers are the type of variable in Python that will allow you to make these kinds of sequences, to make these kinds of groupings. And if you have any problems running any of the Jupyter notebooks, or if you are a little bit lost, just raise your hand and we'll come to you. Where is my back button? Yeah, there's a new one. Okay. Can I get it? Can this is what?
Access this Google account. Problem is that I'm updating.
Okay, it's okay. So the other thing that you can do is, are you on Firefox or, yeah. If you can't do that, the other thing that you can do is you can try to launch it on Binder. And hopefully there is enough. Yeah. It'll take a moment, but it should hopefully not take too long. Binder takes a while to load. But once it's loaded, you'll be able to run everything. in the meantime, the notebooks.
These are already here.
It's already okay. In the meantime, you can look at the text of it itself in here, because at the very least you can read it for the moment, and then once Binder Hub has finished opening it, you'll be able to interact with all the code. But I would suggest that you, at the very least, try to read through it. Yeah, unfortunately I did clear the outputs, so you're not going to be able to see the outputs. Yep. For those of you who are far more familiar with Python, also feel free to, on the main README, at the bottom there's a link to some machine learning notebooks. And so you will be, at the very least, hopefully entertained. I want to see if, excuse me, did you manage?
I said that again because
But quick show of hands, how many people are still working on the notebook for container types? Okay, so once again, we're going to be moving on soon, but I suggest that you try to focus on those 3 goals. Especially indexing and slicing. Those will become very important as you go into the next tutorial.
So I'm going to go ahead and interrupt you now. You've now looked at lists, you've looked at tuples or tuples. I don't know exactly how to pronounce it. I'm going to say tuples. And you have also looked at dictionaries, I hope. And so at this point, we've looked at ways of storing information digitally. We've looked at the different types of variables. We've looked at ways of storing information as sequences and accessible information with some form of indexing, either by the index in the sequence or by a key, right? So you can say in a dictionary, I'm going to look for the name, the age, or whatever other key you gave it. So my next question to you is, what else do you do with computers? Everyone here just uses it to store information and nothing else. So
Process the information.
process the information, very broad, but yes.
Calculations.
You can do some calculations, process the information, do some calculations. You oftentimes, I'm going to assume everybody here is familiar with email, right? So you have at some point sent information to somebody else. You might have used something like Excel and run some calculations or decided to make a nice graph, right? So all of these are tasks. And in order to be able to carry out tasks, you need to be able to tell a computer how to actually do those things. So we're going to look at the following: conditionals and loops. Conditionals are simply a way of trying to make a decision in your code, right? If you have a certain value, you might decide to do one thing versus the other. Think about it this: if you are hungry, you might decide to go eat. If you're not hungry, you decide to not eat, right? Very simple. And these type of decisions are things that you're going to be doing all the time as you're programming. The other aspect that you're going to be looking in the next notebooks are loops. A lot of the times, you want to do things repeatedly. Think of a number sequence. If you want to generate the Fibonacci sequence that we saw before, you need to say, okay, grab the two numbers before and calculate the next one. And you want to do it as many times as you want. And that's what we're going to call for loops. You have a fixed number of iterations, right? You're going to say, I want to do this 5 times, 10 times. I want to do it once for every member in the sequence. Other times, you might want to do something until a condition is met. The equivalent of eating. You eat until you're full. You don't eat 5 bites and decide that's it, right? So do me a favor, open the 03 notebook and become familiar with conditionals, with for loops and while loops. And if you are looking for the QR code, it's there. That was your musical interlude. Once again, a quick show of hands. How many of you are finished with the notebook? Okay. So if you're not, please try to focus on just trying to answer those questions or like get an idea of them in your head. So allow me to interrupt you once again. Hopefully by now you have gone through most of the conditionals and for loops and while loops, right? I hope that that allows you to see how useful it is to be able to repeat code several times and to have checks in your code. How many of you here are tired? How many of you feel warm? I feel warm. But there's only 40 minutes left, so hold on, and then we'll be able to go into a nice lunch break and a nice refreshing glass of water, or whatever else you want to drink. But before we continue, I want to ask you, what happens when you don't have a fixed condition? What happens when you want to do something that's not necessarily repetitive? Well, that's when you get functions, right? So functions are simply a way of handling some amount of input information that you want to do something with, processing it, and then outputting something based on what you input, right? Note that the output is sometimes not necessary. When you decide to, for example, print a message, do you need something other than the message that was printed to the screen? Not necessarily, right? A lot of the times, however, you are quite interested in the output. After all, if you, let's say, train ChatGPT from scratch, and at the end you don't save that, you're going to be very sad. And that brings me to the next point. How many of you here want to implement everything from scratch all the time? Can I get a show of hands? No one. This is surprising to me. So that's where libraries come in, right? You want to use other people's code. Other people have already solved so many problems, right? And one of the great things about Python is the fact that you'll have access to these libraries. For example, the NumPy library, which you're going to be looking at in the next tutorial. But think about these things as you open the next notebook, Notebook 4, which are going to go into how to use functions in Python and how to work with libraries inside of Python. And if you need the repo, there's a link.
Dun, 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 dun. Quick question. How many of you are already done with a notebook? Okay. So I'll give you a bit of a longer interlude, but please try to remember. And if I had to say very important parts, importing libraries and aliases. All right, everyone. So once again, I'm going to interrupt you. Hopefully, you were able to get to the part about importing libraries. It's going to be very useful for the following tutorials. But right now, I have another question for you, which is, how do you think one organizes data and code? Does everybody here want to open up a text document that has, I don't know, 10,000 lines and try and look for one function to see maybe that does what I wanted to do? Yes? If you say nothing, I will assume that's a yes, and I will vouch for this. So, any ideas? So,
Yes. Sorry?
oh,
You just use modules, I think,
you just use modules
and you just separate the code
to separate,
different text documents or modules.
so we can use modules. And what are modules?
Text documents with
Oh.
an extension .py.
With the exception .py. So it's a big old script, but in the script, you're still going to have that same issue. So here's something that I propose. Objects, right? Objects, and modules are a type of object, are ways of trying to hold both data and functions inside of one kind of encapsulated container, right? And so whenever you talk about objects, you're going to look at attributes, and attributes is just a name for the variables associated with the object. If you were to think of someone like a student, right, you could have things like their age, their nationality, the languages that they speak, their GPA, right, the year that they graduate. You might also have some methods, some functions associated to that student. You might have something that prints out the report card. You might have something that writes a small introduction, right? Or that makes a summary or some kind of CV, right? All of these will be associated with the student object, and you're going to be able to access them a lot more easily and without going insane, hopefully. So do me a favor, open Notebook 05, and you're going to go into an introduction to objects.
There's a problem with my Google account. They send me something in 48 hours. So where do I download your
What libraries do you have installed? Do you have Jupyter installed?
up to now I have this one. I have a number 3 and you are on number 5. So what do I have? Where can I download the number 5 and the
You can download them all from the GitHub. Do you have Git installed in your computer? Yes. So you can just clone it.
where?
Hmm?
Because I'm not familiar with GitHub.
It's okay. I'm going to go ahead and go into the PowerShell. Where do you want to store it? In documents?
Yes.
Do you have it in English? You don't have a... Okay. Let's make a folder in your downloads.
Download téléchargement.
Oui. Ah oui, c'est le français.
Oui.
Ok. Donc on peut faire un dossier. On va faire ça. Intro. Hop. Intro. Git clone. Donc on a... Bon, normalement ça va suffire.
J'aimerais que vous m'expliquiez comment vous faites. Je ne comprends rien à GitHub en fait. Et en fait, voilà, je reçois des trucs. Bon, j'ai vu que vous avez renommé en intro, mais ça c'est important pour moi de comprendre au moins ça.
Oui, je comprends. C'est vraiment... l'idée c'était d'utiliser soit Colab, soit Binder parce que c'est plus simple au moment qu'on a envie de suivre un tutoriel parce que bon, c'est dans le cloud. Donc on n'a pas besoin d'installer quelque chose. Binder, il est pas trop vite pour lancer, mais éventuellement ça va marcher. C'est juste que ça prend du temps. Mais sur ici, c'est en train de faire penser en environnement virtuel où tu vas vont se lancer et il y a éventuellement tout ce que vous avez regardé au repo va être là. Mais ça prend... La première fois, ça peut prendre 10 minutes, quoi.
Combien
10 minutes pour ouvrir la première fois. Mais il est toujours en train d'ouvrir. C'est juste parce que c'est dans un serveur quelque part. Donc,
parce que comme j'étais en train de upgrader Jupyter en version 4, je trouvais que ça restait immobile. Alors j'ai tout fermé et j'ai relancé.
oui, ça change éventuellement. Mais
Là, on attend. Là.
oui, il faut attendre et éventuellement ça va ouvrir. Dans un... Et si vous regardez... Si jamais il y a aussi...
Parce qu'il y en a certains qu'on a téléchargés.
Oui.
Et je ne voulais pas chaque fois télécharger numéro 1, numéro 2, numéro 3. Donc enfin, je veux pouvoir me débrouiller tout seul quand même.
Oui, donc si vous attendez quelques minutes,
Oui.
ça va éventuellement devenir ça. Et donc comme ça, c'est vraiment juste Jupyter Lab. Ça va tout être là.
Parce que j'ai Jupyter Lab, mais j'ai le numéro 3.
Oui, mais maintenant, vous avez déjà
Oui.
tous.
D'accord.
Donc ils sont téléchargés, vous pouvez faire ce que vous voulez.
Je peux aller sur 5 alors
Oui. Si vous allez l'ouvrir, ça va juste prendre, je ne sais pas si vous avez lancé déjà Jupyter Lab, mais ça va éventuellement ouvrir. Mais sinon, si on va là, hop, normalement, j'imagine que vous avez installé ça, Jupyter.
Non, Jupyter.
Hop, pardon. Jupyter Notebook. Et ça va lancer sur
Donc
votre
là,
base.
j'arrive sur Jupyter.
Oui. Et là, vous avez ça. Et vous pouvez regarder, il y a Copilot Exercises. Il y a la première, deuxième, lesquelles c'est là que vous voulez.
Et lequel il faut là maintenant
Maintenant, on est au 5e.
5e. Là,
Oui. Ça, c'est local. Vous pouvez tout faire normalement. Si vous allez là, et si vous cliquez sur cellule, et vous faites soit Run, soit Shift Enter. Exécuter. Oui.
Oui, et alors
Oui. Ou Shift Enter.
Comme ça.
Oui. Et donc, ça, il y a eu le output qui est là. Et vous avez regardé qu'il est bien.
Bon, mais qu'est-ce que
C'est
je
bien.
dois faire
Bon, c'est lire, suivre, comprendre, et vous pouvez changer tout ce que vous voulez. Parce que c'est vraiment un petit tutoriel pour
Ouais. Bon, je
devenir...
vais essayer de suivre.
Ok. Sorry, no, it's me. Quick show of hands, how many of you are already finished? Okay, so if you have not finished, please take a moment. I didn't open the other one. Sorry. And here, really, just look at the syntax and become familiar, just because it's important when you're interacting with the libraries that you import to be familiar with the syntax used to access objects and to be able to read the methods that are available or the attributes that are available. Because a lot of the time, you might not be 100% familiar with what's there, and just by being able to look at the attributes and being able to look at the methods, you'll get an idea of what you can do
with a particular object. I'll take this opportunity to interrupt you one last time. So by this point, we've looked at several notebooks going through several themes. I have a very important question for you. Do you have any questions? Any question is valid. I might not know the answer. If you ask me, for example, what is the historical context of programming in Basel? No clue. So no questions. All right, I'll take your word for it. So by now, hopefully, you should be able to look back at the goals that we established at the beginning. And this is essentially my report card, right? Let's see how good of a job I did. How many of you feel that you can describe Python in broad terms? By show of hands. I did a terrible job. I'm trying, I swear. Okay. How many of you feel that you can indicate some reasons to use Python for scientific computing? Okay. How many of you can identify variables and container types? We're improving. Understanding how conditionals, loops, and functions work in Python. Okay. And finally, how many of you have an intuition of how objects work? Look, I'm not expecting you to come through one tutorial session and be like, yes, I am the master of object-oriented programming, right? It's a difficult thing to hold on to. And so I want to thank you, one, for following the notebooks and for playing the game, so to say. And I want to say one last thing. Right now, I did not get a chance to write some notebooks that have to do with what I am sure you have heard of in the news, which is when you use AI to help you code. It's not perfect, but it helps, right? I do plan to develop some quick notebooks to get some exercises going on the type of outputs and inputs that you can expect from something like GitHub Copilot or from ChatGPT. There is just one. That's because I started trying to write them and I ran out of time before having it for the tutorial sessions. My ideal case scenario would have been for them to be ready and for any of you who had finished the notebooks to have gone into the wonderful world of AI-assisted programming. Rather unfortunately, it had ended up being a little bit of a dream. I didn't have enough time. But I do promise that I will do my best to put some exercises on there, right?
We will find them.
Sorry.
Thank you. So, if we are still having the access to this Git in the near future, you'll add those exercises with the Copilot or something?
That is my plan, to add just some quick exercises that will kind of give you an idea of how to use Copilot to process code. I can't promise that it's going to be in the immediate future, but it will be in the near future. And when I develop them, I will push them to the same GitHub repo.
Okay.
So keep the link.
I will take the opportunity to ask you another thing. Maybe I should have, raised my hand before for the questions.
Any questions?
I've seen that the notebooks you shared with us were made with Colab, or at least there is like this Colab link open with Colab. I use Visual Studio Code. I think it's a matter of personal preference. Why do you like Colab over, I don't know, other environments?
So the reason that I made it so that everything opened up in Colab is because there is no prep on your end, right? If I say, here's Visual Studio Code, and make sure that you have these dependencies inside, we would have spent a good time at the beginning just trying to figure that out.
Okay.
You will find instructions on how to install VS Code, and if you're a student, it's very, shall we say, convenient because you can have Copilot for free as an extension. But those instructions are in the 00 markdown file. So if you open that, you will get a quick guide as to how to install Miniconda, VS Code, and everything locally so that you can run your notebooks locally in an environment that is quite useful, right? It also has the instructions for how to install Jupyter Notebook, Jupyter Lab, and Spider, depending on your own preferences, because I know some people might not want to use VS Code.
Little question. So there are basically three options: VS Code. There is also VS Codium, for like a slice official. Then is open source version of VS Code, and Binder and Miniconda, as you mentioned. Like you enumerate them in the notebook by giving any type of opinion, but I'm asking you now an opinion. If you like them, one of them more than another, for which reason? I'm just curious.
So in my development, I have mostly used either Spider, because I don't often use Jupyter Notebooks. I generally write my own scripts because otherwise you have to click through all the cells, and most of the time I'm doing something that's not going to be necessarily interactive. Recently, I changed to VS Code just to have access to Copilot. I am a PhD student, so it is free for me, and having AI assistance is significantly helpful, right? Just because a lot of the times there are some small things that you might have forgotten, and so you have to look at the documentation to have to look at it, and it's not something that is particularly deep. It's just syntax or something that you forgot, and Copilot is very good at giving you base code that you can just then fix to whatever it is that you actually want to do. Sometimes it doesn't really follow the best practices, but I will say that my opinion on Colab is that I use Colab for educational purposes because most people have a Google account. It's simpler and it opens up quickly, right? And so if you already have a Google account, then I think it's
I think it stands up for its name. It's more collaborative than other environments. Okay, thank you.
Right? But Binder is a very good tool, and it gives you full Jupyter Lab, which is better. It just takes longer for it to load. So, and because it is open source, sometimes you might not be able to access it because it's overloaded. For example, this morning when I was trying to open my own binder from which I had already verified worked last night, but I wanted to once again verify this morning. It just told me that there were too many users on that particular binder, and so I couldn't actually open it, right? And so having a fallback option, you can use Colab. There's also another service I think called Gradient. And so there's multiple options. Some you'll see some different ones depending on which tutorials you follow or which conference talks you go to. But there are several options out there. These are just the ones that I thought were more approachable or the ones that I've used for X, Y, or Z reasons. Any other questions? I also take questions on where is the bathroom? At what time do we eat? Okay, so with that in mind, I want to thank you once again for all of your attention and for all of your time. Bathrooms are right across us. At 12, food will be downstairs. Thank you very much.